Hello and welcome to Chapter 2, Chemistry, Matter, and Life. Today we're going to look at a basic overview of Chapter 2. We're going to look at atomic structure and some chemical bonds. And then in a separate video, we're going to look at organic molecules of carbohydrates, lipids, proteins, and nucleotides. When it comes to atoms, atoms are made of protons, which are in the nucleus of the atom, along with neutrons. The electrons move around. It's the electrons and the bonding of the electrons and the interaction of the electrons that determine the bond, which determines the molecule. Now, when it comes to elements, elements are all types of matter. First off, the definition of matter. Matter, I don't like this definition. Matter is anything that takes up space and has mass is a definition of matter. All the elements of the periodic table, all the elements are recorded on the periodic table, and they're all different types of matter. And this is part of the periodic table of elements. There's 112 atoms here. Some go up to 114. These last ones are synthesized in the lab. They're not important in biology. In biology, we look at carbon, which is called the element of life. Then hydrogen and oxygen, which makes up carbohydrates. And proteins are made up of carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. So we say chomps. Those are the main molecules in living cells. Some of the other ones are added to it and they're needed for life, but they're not necessarily the organic molecules. Okay. When we look at some of the elements in the body, carbon, oxygen, hydrogen, nitrogen are the important ones. Calcium are important for bones and teeth. Potassium, sodium, and chlorine are also important, and iron is needed. These are seen as minerals, and if you read on your vitamin, multivitamin, you will see that most of these are taken in. Sodium, not so much. Sodium we get enough from our diet. Okay, when it comes to atoms, atoms are the smallest subunits of the of elements, and they cannot be broken down or changed by ordinary or chemical means. If they are broken down, you end up with something radioactive, which if you want to treat cancer, little radioactivity is good, but too much radioactivity can cause cancer. Quite often we look at radioactive in terms of tracers in dyes, or also in terms of a radiation therapy. Okay. The atomic structure, you have the nucleus at the center, you have electrons that go around the outside. In terms of a little chemistry, there are two numbers that are important for each atom. There is the atomic number, which is usually written on the top, but it's a smaller number, and there is the atomic mass. The atomic number is the number of protons. The atomic mass is the number of protons plus the number of neutrons. Each element has its own unique number of protons. So the example here for oxygen is 8. When you look at carbon, carbon has 6 protons. Nitrogen has 7 protons. So each element has its own unique number of protons. The protons in the nucleus, protons and neutrons are in the nucleus. It's the electrons that are in the outer energy levels. The outer energy levels change and they fill up based on bonding. The whole idea is to fill up an outer energy level, and this is what makes the types of reactions. There are actually two categories of reactions. And these categories, to form chemical bonds, you have electrons that are transferred and electrons that are shared. If you are transferred, you are an ionic bond. In an ionic bond, one atom transfers the electrons completely, and in a molecular bond, they share the electron. I have a little bit of a video here to show you if I can set it up. This video, you can see the URL at the top. There we go, in theater mode. Here we go.
The outer shell of many atoms hydrogen being an exception, holds 8 electrons. Atoms that have an outer shell containing 8 electrons are considered chemically stable. We often say they fulfill what is called the octet rule. When atoms combine to form compounds, they can give up, accept, or share electrons in order to assemble an octet of electrons in their outer shells. A covalent bond is formed when atoms share electrons in order to satisfy the octet rule. For example, a carbon atom holds 4 electrons in its outer shell, but it would be much more stable with 8. To gain the additional 4 electrons, carbon can share with other atoms, and thereby have a completed outer shell. If 1 carbon and 4 hydrogen atoms come together and share their electrons, carbon achieves an octet of electrons. Note that each hydrogen in this compound achieves 2 electrons in its outer shell. This is the stable configuration of the first electron shell. An ionic bond forms when 2 atoms are held together by the attraction between opposite charges. The reaction between sodium and chlorine atoms is an example of how an ionic bond is formed. Since sodium has only 1 electron in its third shell, it has a tendency to give up that electron. Once it does, the remaining outer shell contains 8 electrons. This loss of an electron gives sodium a slightly positive charge. Chlorine, on the other hand, tends to gain an electron, since its outer shell already has 7. When chlorine gains an electron, it becomes slightly negative. The charged sodium and chlorine atoms are called ions. Ions of opposite charge attract each other and form ionic bonds. In this case, the attraction of sodium and chlorine form a molecule called sodium chloride, or table salt.
Okay, so a quick review. Ionic bonds will donate, and when you donate, you become an ion. If you're a positive ion, you are a cation. If you are a negative ion, you're an anion. And then opposite charges attract, and that forms an ionic bond. You can then also have a covalent bond. In a covalent bond, they share. And what happens is they neither lose or gain, so it's like they're both hanging on to the same molecule at the same time, and this way they both fill up their energy level. But they share, so they're not usually as charged. Now this bond can be either nonpolar if they're shared equally, or polar if they're not shared equally. When you look at hydrogen, they're the same size molecule, so they share equally, and hydrogen molecule is seen as a nonpolar molecule. In water, you have this great big oxygen and you have little hydrogen. So when the oxygen comes, it will hold the the electrons closer to the oxygen, and as a result it's more negative on this side and leaving it more positive on this side. Because you have a negative pole and a positive pole, this is seen as a polar bond, and polar bonds come from sharing unequally. Now, when you have a molecule is just a combination of any 2 or more atoms. So you can have molecules of the same thing. A compound are different, and they're normally held together with ionic bonds. Okay, when you look at mixtures, there are 3 types of mixtures that we're concerned with. Solutions, which means it's mixed all the way through and it looks as one. You can have a suspension, which means you have a mixture, but it will be separated. An example of this is salad dressing. If you let salad dressing set, one will go on top of the other. And another one is a colloid. A colloid is a heterogeneous mixture, hetero meaning different, that will then suspend the particles of different size. And intercellular fluid is an example of a colloid. Water is very important in the body. It is the most abundant compound in the body, and a deficiency of this will cause a threat to our health. It is also seen as a universal solvent, and one of the reasons it's a universal solvent has to do with that polarity, that positive and negative that we talked about here. This positive and negative is very important at attracting and bonding with other molecules. Okay. When it comes to mixtures, there are pH. pH has to do with the acidity or the alkalinity. The more acidic you are, the lower the pH. The more basic you are, the higher pH. And if you're at 7, you are neutral. Weak is towards 7, and the farther away you get is seen as strong. So stomach acid is a very strong acid, where milk is at 6.5, so it is a weak acid. Same thing with on the base side. Sodium bicarbonate, which is baking soda, is a weak base because it's only slightly away from 7, where lye or oven cleaner, sodium hydroxide, is a stronger base. Okay. Usually with the properties of bases, they have hydrogens in acids and hydroxides in the bases. Radioisotopes are another type of molecule we want to look at. An isotope is something that has the same number of protons but different number of neutrons. Isotopes are often radioactive and unstable, and these are used in nuclear medicine. In terms of thyroid, you can use radioactive iodine or radioactive cobalt. Okay. We are going to look at organic compounds in a separate video because I want to go into more detail about carbohydrates, lipids, and proteins. So that's enough for Chapter 2, Part 1.